If we give you one like this, 3, 6, 12, 24, and let's make the sign between them plus. That's a series now. What's the next number? 48. And I say I want to add them all the way to infinity. Well, you can't add them to infinity because you can never reach infinity. That number keeps getting bigger and bigger and bigger and bigger and bigger. What is R for this series? R is going to be what? Isn't that each number is twice the number before it? So you say, well, that's a geometric sequence, basically, except with the plus sign between them. It makes a geometric series there. So if you want to find the sum of them, let's say the sum of the first 1,000. 1,000. Well, the equation says A1 times what? 1 minus R to the power of what? N over 1 minus R. 3 times 1 minus 2 to the power of 1,000 over 1 minus 2. That number is going to be infinite, huge number. Your calculator will not be able to do it. Can your calculator do that, 2 to the power of 1,000?
No, but we can do the...
Couldn't do it. Too big. It does not have a sum. It goes to infinity. Infinite. It gets bigger and bigger and bigger. You're adding more and more numbers, bigger numbers and bigger numbers and bigger numbers. That sum is going to be an infinite. So you can't have an infinite summation if R is more than 1. It's going to be infinite. You can't add them. If R is more than 1, any number more than 1, when you raise it to the power of 1,000 or 1,000,000, it's too big of a number. You can only add them, find infinite summation if R is less than 1. So let's pick a problem where R is less than 1. So for example, here we go, 6. We'll use a third of that. What's a third of that? 2. Next one, a third of that. 2/3. Next one is a third of this. 2/9.
Oh, wait, what?
So what is R equal to here? 1/3. Each number is 1/3 the number before it. Now watch what will happen if I say, what is S to the 1,000? And I'm looking for not just 1,000, I'm looking for infinity. S million, billion, gazillion, whatever you want to use here, a huge number. But we'll start with 1,000, just to show you what's going to happen there. It's going to be the first number, 1 minus 1/3 to what power? 1,000. The bottom is negative 2/3, right? This is 6 times 1 minus. Let's see what the answer to that one. Hopefully you make sure you put the 1/3 in parentheses here.
Yes.
Raise it to the power of 1,000. That's going to go to 0. Every single time.
Anything that's smaller than 1 is going to go to 0.
Anything is less than 1.
Yeah.
When you do infinite summation, it means I want to add infinite of these, not just 1,000. We normally want to add way more than 1,000. I'm just showing you an example with 1,000. So what will happen to this term? This goes to what? 0. So the equation becomes, if this is going to go to 0, then what's going to happen to that equation? It's going to be S infinity. It's not going to be, it's going to be A1 times 1, which is A1 over 1 minus R. And that's the equation we're going to be using. Because that piece goes to 0. And if it goes to 0, you end up 6 times 1, which is just 6, over negative 2/3. This is negative. Oh, that's 2/3. That's 2/3, yep. Will be 3 times 6, which is what? 3 times 6 is 18 divided by 2. and the sum will go to 9. That doesn't go to 0 now. I'm just showing you it will go to 0, but when you look at the notes, I don't want people to think that always goes to 0 here. Only goes to 0 when r is less than 1. So that's the equation we're going to be using in this section. Infinite geometric series for r less than 1. When r is less than 1, this is what the infinite series is going to add up to. The sum will add up to that number.
When r is less than 1.
Yep. That's the equation we're going to be using.
Infinity is the same whether it's plus or minus, because the first one is a negative infinity.
Well, we're adding the infinite summation. Like all of these. There's no because you're counting how many of them. So you can't really have negative infinity.
Well, look at the first one, the S1000. That 1 minus 2 is going to be a negative numerator.
1 minus where? Here?
No, yeah, in that
Yeah,
one.
that'll be a negative number, so is this. Right?
Oh, okay.
So negative over negative, still positive. I'm thinking of a number here. Let's see. Okay. So how is that going to help me? Where is it going to help me? I was pushing buttons on my calculator to find some number. And I said, okay, take this number. It's a repeating number. And I want you to change that to a fraction. Don't push the button there. Leave them alone. You're trying to guess on the calculator, pushing the button there. Which number is it? Well, when you look at that number, can't be 2 over 10. That'll be 0.2 even. That'll be what? Isn't that 0.2 plus 0.02 plus 0.002 plus 0.0002 this plus this plus this plus this, and keep going all the way to infinity. So if I know the sum of these numbers, it should equal to this one. Well, let's look at these numbers. What do you think r equal to here? If you take 0.02 and divide it by 0.2, what are you going to have? 0.02 divided by 0.2. 0.1. If you took 0.002 divided by 0.02, what do you have? 0.1. If you took 0.0002 divided by 0.002, 0.1. What you have is geometric series. Each number is 0.1 times the one before it. What's 0.1 times this? That's that number. What's 0.1 times this? That's that number. What's 0.1 times this? That's that number. So what's the sum of that? Infinite, all of them, if you add them. Well, the equation says that's a1 over what? 1 minus r. What's my a1? 0.2. 1 minus r. What's r? 0.1. What do we have? 0.2 over 0.9, which is what? 2 over 9. And that's the answer to 0.2222. Yep.
That's kind of cool. Wait, what? You can just drop the decimal point and go.
Yep, all right, 2 over 9. That's what it's equal to. This is equal exactly to that. Now, some of you guessed that number. I'm glad you did, so let me try something where you can guess. Ready?
Yeah.
I'll make sure you can guess it. And I have no idea what that answer to this. Okay, I'll make it even more challenging. 0.8, 2, 2, 2, 2. Put a twist in it. Good luck pushing the button now.
9 over 10.
This one? 9 over 10 is 0.9. You're right or wrong, I know that. I don't have to push the calculator there.
Alright, let's look. 9 over 11.
This one is different. You got to break it down to 2 parts. The only part that's repeating is the 0.2222. So this is actually 0.8 plus 0.0222, like that.
You're going to divide the problem into 2 sections.
Yep. This part doesn't repeat. That's that repeats.
Yeah.
The 0.8, I know that's 8 over 10. We all know that, which is 4 over 5. That's the 0.8. But what about that part? Well, let's look at that. I can write that 0.02 plus 0.002 plus 0.0002, and it keeps repeating.
So we figure out the right side first and then add it.
Yep. We figure this side. Let's figure with this as a fraction, then we'll add the 2 pieces. So what is r equal to here? Try again. Is it 0.1?
0.01.
I don't know. It could be. I think it might be 0.1. You might be right.
0.1, yeah.
It is 0.1.
So it would have
Every
been
time there's one way
Yep.
out.
1 9 would have been right.
If you divide this by this, is 0.1. If you divide this by this, is 0.1. That's what r is, 0.1. So to get the sum here
A1.
is going to be a1 over 1 minus r. a1 is 0.02 divided by what? 1 minus 0.1. 0.02 over what? 0.9. You got to move the decimal point how many places? Twice. That'll be 2 over what? 90, which is equal to what? 1 over 45, right? So the first part is 4 over 5. The second part is what? 1 over 45. What's the LCD here? 45?
So times 9. 9 times 4,
36 here, plus 1.
37 over 40.
Let's see if that's true. Get your calculator handy.
Yeah, it is.
37 divided by 45. What do you know? The stuff actually works.
Is there a method that you could just go to there?
Yeah, you know.
Like what the genius is? There's something the geniuses know that he can know.
Well,
You know?
they're teaching you that. Somebody figured that out. Now they're teaching us that.
Well, 37 and 45 are the two things that they're not looking at right away.
Yeah, just by looking at it, you saw that. I can tell that. Yeah. I think I'm insulting you here by going through the math there. So that's the advantage, actually, why we look at that method. You know, why we're interested in it.